Now let's look at solving an equation involving a radical. All right, so we have the equation 2x equals 1 minus the square root of 2 minus x. So we want to get rid of the square root. What you don't want to do is just square at this point. If I square here, right, this would become 4x squared, and that's no problem. But look at the other side. All right, so 1 minus the square root of 2 minus x. Oh, by the way, don't write this in yet. Let me show you a better way. That's the same as 1 minus the square root of 2 minus x times 1 minus the square root of 2 minus x. So on this side here, that's going to be 1. We're going to have negative 2 times the square root of 2 minus x. And then this would be plus, there's a square root of 2 minus x times the square root of 2 minus x. That would be a square root of 2 minus x all squared. So you'll get rid of this one here. But look at, you made this worse. Right? You made this equation much worse than it was to begin with. So make sure before you do any squaring that you isolate your something squared. All right? So isolate that square root on one side. All right? And then square. Actually, well, not the whole thing. So we're going to isolate the radical, and then we'll square. And that would be true no matter what, whether you had a square root, a cube root, etc. So we have 2x equals 1 minus the square root of 2 minus x. Before we do anything else, let's divide by, let's subtract 1. So that's going to give us 2x minus 1 equals, careful, there is a negative sign right here. Point that out. Oops. All right, so there's a negative sign right there. Yeah, there we go. So make sure, oops, that you get rid of that as well. So we have negative square root of 2 minus x. How do we get rid of the negative? Well, of course, we divide by negative. So the signs will change here. So we have negative 2x plus 1. Divide each one of those terms by negative 1 equals the square root of 2 minus x. All right, now we've got our something squared isolated. All right, so I'll even write that in. Something squared. Excuse me, not something squared. Sorry, I'm thinking of something. That's what we're doing in Algebra 2. Our radical is isolated. Now we can square. So that's going to give us negative 2x plus 1 equals the squared equals the square root of 2 minus x squared. The square and square root will cancel. This is just a 2 minus x. All right, and then if you remember the pattern, all right, so this is the same as negative 2x plus 1 times negative 2x plus 1. All right, so you're gonna have, the first one's going to be squared, so that's going to be a positive 4x squared, right? Because you've got a negative 2x times a negative 2x, because when we're squaring, we're multiplying something by itself. And then we have minus 4x plus 1. Let's get everything on one side, so our equation is set equal to 0. So we'll subtract 2 and add x. So that gives us 4x squared minus 3x minus 1 and equals 0. And I wrote too big. Let me see if I can move everything up. Oops. Let's move that up just slightly. And I'll get rid of that random stray mark here. Okay, there we go. All right, so 4 times -1 is -4. We need two numbers that multiply to give us -4, but add to give us our b term of -3. I hope you realize that's -4 times 1 and -4 plus 1. So we have 4x squared minus 4x. We're just replacing that -3x with a -4x and a positive x, plus x minus 1 equals 0. And there's just not enough space over here. Let's see, I'll move it up one more time. Oh, there. All right, let's pull everything up one more time. Then we can get the last of our equation in. And let's put this over here. All right. So now, pull out a greatest common factor. That'd be 4x. We'd be left with an x minus 1. Greatest common factor for x and 1 is 1. And that's okay because we have a repeating binomial. So one factor is x minus 1. The other is 4x plus 1. And we have two solutions. We have x minus 1 equals 0. That would make x equal to 1. And we have 4x plus 1 equals 0. That makes x equal to -1/4. Right? Subtract 1, divide by 4. On the next page, let's check our solution. Make sure we don't have any extraneous solutions. And so I'm just going to clone this page. Right? And we will clear it. Somehow I got 3 of them again. All right, clear ink. So it was 1 and -1/4. All right, let's plug in the 1. So we have 2 times 1 equals 1 minus the square root of 2 minus 1. All right, so that would be 2 equals 1 minus 2 minus 1 is 1. And the square root of 1 is 1, so we have 2 equals 1 minus 1, 2 equals 0. And 2 doesn't equal 0. This one is an extraneous solution. Right, it was an answer we got from solving, but when we checked it out, we found out it was no good. No bueno. All right, let's check the equals -1/4. So that's going to be 2 times -1/4 equals 1 minus the square root of 2 minus -1/4. I wonder if we're going to have any solutions. Just double checking. Let me just double check and make sure there was no sign errors or anything like that when I wrote it down. No, I don't see any. Okay. All right, so this is going to be -1/2. That'll reduce equals 1 minus the square root of 2 plus 1/4. That's not going to be a perfect anything, because that would be, oh, yes, it will be. Oh, never mind. Never mind. I was thinking of 2 1/2. 2 1/4. 2 is 8/4. 8/4 plus 1/4 is 9/4. So this will be 9/4. We can take the square root of 9/4. That's -1/2 equals 1 minus. That would be 3/2. And that is a true statement. So I was starting to worry maybe we get no solutions, but we got one good solution. So this is a solution. X equals -1/4. Right? And in the next, and so let me just go over one thing and then we'll talk about the next video. When we solve an equation, we may end up with one or more extraneous solutions. That is, potential solutions that do not satisfy the original equation. In example 10, the value x equals 3 is an extraneous solution, and in example 11, the value x equals 1 is an extraneous solution. In the case of equations involving fractional expressions, potential solutions may be undefined in the original equation and hence become extraneous solutions. So we can't have 0 in a denominator. In the case of equations involving radicals, extraneous solutions may be introduced when we square each side of the equation, because the operation of squaring can turn a false equation into a true one. For example, -1 does not equal 1, but -1 squared does equal 1 squared. Right? Sometimes that squaring makes something seem like it's a solution. Thus, the squared equation may be true for more values of the variable than the original equation. That is why you must always check your answers to make sure that each satisfies the original equation. And the equations that we have to check our answers are rational equations, radical equations, and that's, let me specify that. That's if we have an even root. Then the odd ones don't do this, but it's the even roots where we get those false solutions. And then the other one is logarithmic equations. We can get false solutions there. For instance, we can't take the log of a negative number. So these three equations, we always have to check our solutions and make sure it works out. So thanks for watching. Bye for now.